three resistors. We have two in parallel in series with another one here. So this will be our series resistor, and these are the two parallels. Our PVIR chart is organized down here. These are the two in parallel. So we need to add those first to get the combination. And then we'll be in series with the resistor R1, and we'll get R total that way. So let's go ahead and get the R combo. So I'll say 1 over RC is equal to 1 over 5.1 plus 1 over 3.3. Okay. And that gives us a value of 2.0 for the combination or the parallel. Now to add the resistor 1 to the R combo, we will just add those two together and get 4.2. Okay, now our units are actually in kilo ohms, and all these are in kilo ohms here. Look at our circuit. There's 18 volts for the total voltage, and that'll be on the total resistance then. So we use this chart here. Volts is equal to the product of current times resistance. Therefore, current is voltage divided by resistance. So I'll take 18 divided by 4.2 and get 4.29, and that'll be milliamps. And I'll record that all the way through our combo here. I'll put a little dashed line here, or we'll look at this line here and then note that that's the separation line. This part here is the parallel part, and this part here is the series part. Okay, now we have our current. Notice how the current's the same for all of those in series. All we got to do now is multiply resistance times current for each of those in order to get their volts. So 2.2 multiplied by 4.29 is 9.43 volts. And 2 times 4.29 is 8.58 volts. And what I'll do is write that 8.58, the remainder part, which is our parallel part, 8.58 volts for both of those. And now one more time, I can get current for those by taking 8.58 divided by 5.1, and that'd be 1.68 milliamps. And 8.58 divided by 3.3 is going to give us 2.60 milliamps. Again, see how we're obeying all of our units here. We're in kilo ohms, therefore milliamps. But when we multiply kilo ohms by milliamps, we do get regular volts. Now let's get our power. Well, power, the equation is always a product of current times voltage. So we're set up perfectly to get all those. We'll multiply all of the currents by all of these voltages here, and then we will record the milliwatts there. So this will be 77.2 milliwatts, 40.4 milliwatts, 36.8 milliwatts, 14.4 milliwatts, and lastly 22.3 milliwatts. And that's how we do it for the circuit. Now that we have everything figured out, let's just look at the general patterns again. The series part, we have all the currents the same, and we have voltage dividing going on. So 18 volts is then going to be divided into 9.43 on the 2.2 ohm resistor and 8.58 on the combo. These two would add up to be your 18. Okay, and then look at the parallel part. We have 8.58 volts on everything there. And then it's a current divider circuit. So we have 4.29 amps or milliamps for the R combo. And look how it gets divided to 1.6 milliamps and 2.60 milliamps. Total power of the circuit is 77.2. And each part has its own unique power because we use the equation P equals IV.